Welcome all to Selective High School Placement Trial Test, Power Thinking Skills Test 27. Question 5. If true, which one most weakens the above conclusion? So what is our conclusion? We have our magic word here. Therefore, we should prioritize getting an easily readable font on our road signs. And why? It says here because it's one of the key features. It's that it is readable and can be easily interpreted. So they're emphasizing that this legibility, okay, how readable our signs are, is actually the most important fact about road signage. What would weaken this conclusion? Well, we need something that will directly oppose this conclusion, i.e. saying, no, in fact, that is not the most important thing, okay, readability. So the statement would be option D. The main purpose of road signage should be to guide as clearly and comprehensively as possible, not just be legible. So that directly argues against or rebuts this statement. Okay, so D is the best answer here. All right, 17. So again, we have two die, but they have different numbers this time. Daniel wins the game if the numbers on the die multiplies to an odd number. Daniel says, I have an equal chance of winning or losing the game. Let's see if it's correct or not. What is his chance of, so first of all, how do I get an odd number? Remember what we said in the past, okay? If you multiply anything by an even number, even an even number itself, it becomes even, no matter what. So the only way of getting an odd number, okay, is for it to be odd times odd. So we're going to see in dice 1, what is the chance of getting odd? And in dice 2, what's the chance of getting odd? And we multiply it together to find the multiplication chance. First for dice 1, the chance, we have 3, 7, and 9. So the chance is actually 3 out of 6. What about dice 2? 6 because it's total number. Okay, there's 6 numbers. We have 7, 11, and 13. So it'll be 3 out of 6 again. We're going to times these together. But before we do that, we can simplify. We know that 3 out of 6 is just a half, isn't it? We have half and we have half. What's half times half? It's a quarter. So that means he has a 25% chance of getting odd result. So what does that mean? He has 25% chance of winning, because remember you need an odd number to win. Now Daniel says he has an equal chance. What does equal chance means? It means 50%. Obviously 25% is not 50%, so this is incorrect. And Daniel he's more likely to what? He's more likely to lose than win, okay? His 25% is less than 50%. So that means he has a bigger chance of losing than winning. 25% winning, 75% losing. Okay, so the next question. 18 and 19 are related. And this one I really highly recommend you to set up a table, okay, to organize your information. The beauty of this question is that, let me just draw it up while I'm talking. Each boy can only have one color, okay, of each toy, okay? And also, there's only, each of the 4 toys are all unique colors. So that means that every toy and every person will have a different colored toy. Okay, I hope I explained that well. But what we're going to do is set up a table. I'm going to write the names here. Okay, they have Alan, Bill, Colin, David. I'm not going to write the whole thing, but you get the idea. And across the top, we are going to write down the toys. We have a car. We have a bike. We have a book. And we have a ball. Now from here, we're going to start filling in what we know. You might notice that these first two, we know that there are 4 of each toy in one of 4 colors. Okay, and the colors are yellow, red, green, blue. These first 2 lines Alan's car, Bill's ball, blah blah are the same color. David's actually we'll just do that line first, okay? That line is impossible to solve right now, okay? Because we know they're all the same color, but what is that color? So I recommend you to look for these direct sentences first, okay? The ones that straight away tell you what someone's toy's color is. And here it says David's book is yellow. So David, for book, we'll write Y for yellow straight away. That's done. Again, Colin's car, blah, 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 the same color. We can't work this out just yet. I'm going to move on to the next one. David's ball is green. You know that David's ball is green and his bike is not red. This is really important because remember we only have 4 colors, okay? Each of the boys has to have one color each, okay? They have only one of each color. So his bike is not red, yellow and green are already taken. So the only leftover is blue. So his bike must be blue, and that leaves his car to be red. There's no other option, or else it'll be repeating. Good, so that's done. Bill's car is blue. Okay, so Bill's car is blue, and his book is not yellow or green. Again, book's not yellow or green, blue's taken, so his book must be red. Now between bike and ball, we don't know which one. Okay, we don't know, but we are going to see if we can figure it out. Now we know Colin's book is blue. Where's Colin? Colin's book is blue. Now, I need you guys to notice when there's one missing column, or one missing in a column, or one missing in a row, that's actually a sign for you to fill it in straight away. Because remember, you can only have one of each color, okay? And each ball can only have one of each color as well. So that means the leftover here is, we have red, blue, yellow, so here we have to have green. Let's use another color, green, okay? So Alan's book, not sure what's happening here. Alan's book must be green, okay? Okay, so now we're going to go back with this information. Let's go to this one. We know that Colin's car, Bill's bicycle, and Alan's book are all the same color. We just figured out what Alan's book was. It was green. Okay, it was green. So that means that Colin's car is also green, and Bill's bicycle is also green. And I told you, like before, we have multiple columns and rows that have one left over. We can just fill it in. Okay, so that means that Alan's car must be yellow. From here, let's go to this one. Alan's car, Bill's ball, and Colin's bicycle are the same color. So we have Alan's car is yellow, so Bill's ball must be yellow, and Colin's bicycle must be yellow. So now I can fill in the blanks, okay? Here we have yellow, blue, green, so this must be red. Green, yellow, blue. What's left over? Red. And this one, yellow, red, green, blue. And now you double check that none of the columns or rows have 2 of the same letters. They don't. So that confirms that you are correct and you've solved it out, cracked the case. Now for the question, who has the blue ball and red bicycle? Let's get a highlighter and a different color. Blue ball is here and red bicycle is here. Okay, so it's Alan, isn't it? Alan is the owner. Next one, what color is Colin's ball? Colin, and then we have ball. It is red. So B is your answer here. So it's actually really worth it to set up that big table. It might be a bit of a bother in the beginning, but there's 2 questions for it, so you can save time in the long run. All right. Next one, if true, which one most weakens the above conclusion? So they ask us to find the conclusion. The conclusion is at the end. Given the unusual weather that day, it is understandable that the bridge, the Tacoma Narrows Bridge, failed. Okay, so that is the main conclusion. And why did it fall? Because of unusually strong winds. Okay, it caused the bridge to wobble and it collapsed. So what would weaken it? What would weaken the fact that this person said that it was understandable? Okay, it was understandable that it failed. The answer is C. Engineers are taught to design structures to withstand virtually any force. This directly rebuts the unusual weather conditions. So they're saying no matter what the weather conditions may have been, engineers should have designed this bridge to be stable enough, okay, to not fail under any conditions. So that would directly link to this argument and also weaken it the most. Okay. Question 22. We have 5 methods of how the Year 5 students came to school. We are missing the bus number. The mean, that means average, of the 5 methods is 14. So then we figure out how many came by bus. If the average is 14, okay, what will the total be? Remember, average is just the total divided by the number of methods. We have 5 methods, so working backwards, the total will be 14 times 5. And when you work that out, that would be 70. Now, we have 4 out of 5 of the methods, so all we have to do from the total is minus what we have right now, and we'll find the bus number. So let's add it up. 4 twos are 6 plus 7 is 13, carry the 1, 3, 9, 12, carry the 1. 1, 2, 3, 4, 5, 6, 62. So we're just going to minus 62 from here to figure out the bus number, and we get 8. So B is our answer. 24. This is a speed related question. So this train is traveling at 60 kilometers per hour and it took 6 seconds to pass him. So imagine that the train is coming here through a tunnel, okay, and from the point where the man starts, okay, and he sees the train, okay, it's moving this way, by the point where the train is going this way and it's already gone past him, okay, this length would have passed him fully. So to figure out that length, we want to figure out how many kilometers or meters this train traveled in 6 seconds, or the duration that it took for the whole length of the train to pass this man. So 6 seconds, we need to change the hours into seconds, okay? So we have 60 kilometers per hour, which is 60 minutes. That means that per minute, it traveled 1 km. We don't want minute, we want seconds here. So what is 1 minute? It's 60 seconds, isn't it? We want to get to 6 seconds. What do? I divide it by 10. I want to divide this by 10 and I get 0.1 km. If you look at the options, you don't have 0.1, so let's change it into meters. 0.1 of a kilometer is 100 meters. Okay, so in the 6 seconds, it would have traveled around 100 meters, which is option D. 26. This was more of an approximation question. Okay, I'm going to try and explain it to you. So, the important thing here is that the chocolate factory only used 500 grams of sugar for each product. That was the maximum. Okay, and each of the products need different amounts of sugar. Here, for example, here, and here. Okay, what you have to do is divide 500 by the respective amounts to see how much chocolate or how much of the lollies you can actually make. And from there, you can times it by the amount it costs to make it. Okay, so for chocolate, I'm going to give you an example. You have 500 grams and you're going to divide that by 45 grams. And you get 11 with a remainder of 5. We can't use this remainder, okay? So we're going to only take the 11. What does that mean? Because it's 11 times of 100 grams, okay? It means that there was actually 1.1 kilograms of chocolate produced. Each kilogram is sold for $5 per kilo. So we're going to times that by $5 and we get $5.50 for chocolate. Now let's try lollies. For lollies, it was 500 grams divided by 55 grams. and you get 9 remainder 5. Remember, we can't use the remainder, so I'm going to use the 9. Okay, what does 9 mean? 9 times of 100, 900 grams, or 0.9 kilograms. I'm going to times that by how much the lollipops are sold, 6.5 per kilo. When you solve that out, you get 585. So from here, let's try and see if the answers can be figured out. C is out from the chocolates and A is out from the lollies. So B is your answer. And obviously you can check with the gummies as well. So that actually concludes this exam revision. Hopefully you guys learned a lot. Again, please revise all the questions if you require to, and also look at these takeaways again and try to apply it for your next exam. Good luck for that, and I will see you next week.